So hey guys, I hope you're having a fantastic day today. So in this video, we're going to talk about arithmetic sequences. But first, I recall about sequences. So a sequence is just a listing of numbers. A plain old and regular sequence doesn't require any pattern. You're just going to list a number, a set of numbers, and you have a sequence. But in an arithmetic sequence, it is a sequence where succeeding terms in the sequence differ by a constant amount. So yeah, first I'm just going to give you a glimpse of idea of what an arithmetic sequence is. So we're going to have some examples. So okay, determine which of the following sequences are arithmetic. If they are, give the value of d. So we're just going to talk about the value of d. The idea of an arithmetic sequences is simple. Notice that from 3 to 8, you need to add 5. And if you're going from 8 to 13, you need to add another 5. And if you need to go from 13 to 18, hey, that's another 5. And the patterns goes on. So as you can see, you just need to add 5, and assuming that this pattern goes on continuously, we can call it as an arithmetic sequence because every term is different by a constant amount. So that constant amount is what we call the d. So our d here is equal to 5. And this is an arithmetic sequence because, as we said a while ago, the arithmetic sequence differs by a constant amount. And the constant amount here is 5. So the next example of a series is 2, 4, 6, 8, 10. Seeing this, we could already say that it is an arithmetic sequence with a constant value of 2. Because if you're going from 2 to 4, you need to add 2. If you're going from 4 to 6, you need another 2. And another 2. And another 2. So, assuming that this pattern goes on and on, we can say that this indeed is an arithmetic sequence with a common difference 2, which you'll need to add to get the other terms. Another example of a sequence is 1.6, 2.2, 2.8, 3.3, 3.9, and so on. So notice that if I add a 0.6 to 1.6, I would get 2.2. And if I add another 0.6 at 2.2, I'll get 2.8. But if I'll add a 2.8 at 3.3, I think I'll get 0.5. So if ever you encounter this, stop, because it's not an arithmetic sequences. Because the term is not constant. The common difference is wrong. Okay? So, even though that all of the numbers will be 0.6, all the common difference will be 0.6, but if you get a different number, just stop because that's not an arithmetic sequence. So let's go to the next example. So the next and last example for this topic. Okay? So notice that if we go from 1 to 6, we'll get 5. If I want to go from 6 to 11, we'll get another 5. And from 11 to 16, we'll have another 5. Oh, excuse me. There. So, assuming that this pattern goes on, we can say that this is an arithmetic sequence. With a common difference, 5. Since we all understood what an arithmetic sequence is, let's move to the next level. So, formula for the nth term. So, in this formula, a sub n here refers to the number of terms. And our a sub 1 here refers to the first term. The d here is our common difference. And our n here is the number of terms minus 1. Okay? Yeah. So I'm going to justify the formula of the n term. So first, let me teach you that this 3, or the first one in the term, is called the a sub 1. The second term is called a sub 2. The third term is called a sub 3. So this 18 is a sub 4. And so on and so forth. So the a sub 1 is equal to 3. And it is said that our common difference is 5. So a sub 2 is equal to 3 plus 5. A sub 3 is equal to, we could write just 8 plus 5, but I'm going to write it as 3 plus 2 times 5. And a sub 4 is equal to 3 plus 3 times 5 because I used 3 5s. So as you can see, it's just the same, but this are changing, which give us a sub n is equal to a sub 1 plus n minus 1 is equal to d. So a sub n is the number of terms. So if we're searching for a sub 5, we just need to find the value of a sub 1, which is 3, plus the number of terms, which is 5, minus 1 is times d. Oh no, it's the equals, it should be times d. Yeah. Okay. So a sub 5 is equal to 3 plus 4 times 5. So a sub 5 will be 3 plus 20, and a sub 5 is equal to 23. So yeah, justifying this, a sub 3 a sub 4 and a sub 5 and other a subs can be found using this formula. So let's have another examples. Suppose we'd have an arithmetic sequences 3, 8, 13, 18, 23, just like what I have given a while ago. Okay? So a sub 10, actually it's easy. The term needed, if the term needed is just small, we could just do it manually by listing it. So 1, 2, 3, 4, 5. I just add the common difference 5. So 26, 29. Oh no, not 29. 26, 31, 36, 41. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and another one, 46. So there. We could say that a sub 10 is equal to 46. And we can do it more algebraically by using the formula a sub n is equal to a sub 1 n minus times n minus 1 times d. So, okay, a sub 10 is equal to a sub 1, which is 3, times 10 minus 1, which is 9, times 5. So, 9 times 5 is 45, plus 3. So, a sub 10 is equal to 48. Wait. Did I? Oh yeah, no. I'm so sorry. So 23 plus 5, this should be 28. Then 33. Then 38. Then 38 plus 5 is 43. And this is 48. Sorry, my mistake. I messed up. Big time. So yeah, if you're doing it algebraically and just small numbers, we could find that a sub 10 is equal to 48. But in cases like the second one, which is a sub 202, if you're masipag enough, you can list it all down, but I'm suggesting that to remember this formula all the times. So yeah, a sub 202 is equal to a sub 1, which is 3, times 202 minus 1, which is 201, times d, which is 5. So, if my arithmetic is correct, we will get 3 plus 1005. Yeah, sounds better. Okay, so a sub 202, or the 202nd term, is equal to 1008. So let's have a harder example here. Suppose we have an arithmetic sequence. So a sub 8 is equal to 25 and a sub 14 is equal to 43. So some may find this hard, but I think we just have to fill in what we know. So using the formula a sub n is equal to a sub 1 plus n minus 1 times d, I think we could solve it. So, okay. So, we were given that a sub 8 is equal to 25. So, substituting this, we get a sub 1 plus 8 minus 1 is 7 times d is equal to 25. And a sub 14 was said to be equal to 43. And substituting, again, we get a sub 1 plus 14 minus 1 is 13 times D is equal to 43. So we have two equations now. This is equation 1 and this is equation 2. So to get the a sub 1 or D, we just need to substitute this and equate it. So equation 1 plus equation 2 is equal to a sub 1 plus 7D is equal to 25, and a sub 1 plus 13D is equal to 43. So what I'm going to do is I'm going to multiply this by -1 and leave the other as it is. So the signs will change. Negative a sub 1 plus it's minus 7D is equal to negative 25 plus it remains a sub 1 plus 13D is equal to 43. So we could cancel this and this. Okay. So this will result to 6D is equal to 25, negative 25 where she is 18. So divide both sides by 6 and you get D is equal to 3. So we have the first answer, which is 3. So I think I'm just going to use one of my equations to find the remaining question or mystery, which is a sub 1. So I think I'll use my first equation. So a sub 1 plus 7 times the common difference, which is 3, it will be equal to 25. So a sub 1 is equal to 25 minus 21 since I transposed it. So a sub 1 will be equal to 4. So voila, a sub 1 is equal to 4. So see, it's not that hard. You just need to believe in yourself and don't lose confidence. Just make sure that you know arithmetic sequence by heart. So if your teacher asks you like what's the common difference of a sub 10 and a sub 14 or something like that, you can solve it. Just fill in what you know and I think you'll get it right. So our last topic for this video is finding the sums of infinite arithmetic series. So in finding the sums of finite arithmetic series, the sum S sub n of the first n terms of an arithmetic series with a sub n is equal to a sub 1 times n minus 1 times d is S sub n is equal to n divided by 2 times a sub 1 plus a sub n, or S sub n is equal to n over 2 times 2a plus n minus 1 times d. So yeah, I found this topic really hard when we had in our exams. I keep on repeating and repeating it because I don't know which formula to use, but then I realized after how many activities that is just the same, that everything will work out. Just find the formula which suits the question, and that's it. You'll have a high grades in your quiz. So let's have an example. Okay? Consider the arithmetic sequences 2, 5, 8, 11, 14, 17. So the first question is to find the sum of the first 10 terms. So what we need to do is use the formula. We just need to substitute it. At this question, I'm going to substitute with the formula, with my second formula, S sub n is equal to n over 2 times 2a plus n minus 1 times d. Okay? So, what's the here? Okay. So, S sub n is equal to n over 2 times 2a plus n minus 1 times d. So, I need to find the first 10 terms. So, S sub 10 is equal to 10 over 2 times 2a sub 1 a sub 1 plus 10 minus 1, which is 9, times the common difference, which is 3. So, S sub 10 will be equal to 5 times 2a sub 1, so 2 times 2 plus 27. So, S sub 10 is equal to 5 times 31. So, our S sub 10, or the sum of the first 10 terms, is equal to 155. So yeah, that was the easy part. S sub 10 is equal to 155. So the last part of this question, this video is kind of tricky because we need to find the number of terms that we need to solve or sum up. And if we're not careful enough, we could mistake it as from 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 to be a number of terms. But from 11 to 18, you need to get 18 terms. Why is that? Because n is equal to 28 minus 11 plus 1. Because if you're going to subtract 28 directly from 11, you'll get 17 terms, which will not suffice the question. So, given the example, I'm just going to subtract. I'm just going to my formula again. The S sub n is equal to n over 2 times 2a sub 1 plus n minus 1 times d. Okay. So, since we're finding 18 terms, this should be S sub 18. It would be equal to 18 over 2 times 2 times the first term, which is 2, plus 17, which is 18 minus 1, times d, which is 3. Okay, so S sub 18 is equal to 9 times 64 plus 51. Okay, so it will be 9 times 115 is equal to 1035. Am I right? Yeah. So S sub 18 is equal to 10,035. 1035. I'm sorry. Yeah. So this sums up my video for the arithmetic sequences. Yeah. So this topic was kind of hard to me because when we first took it, I didn't really review, and that made it hard. I refused to understand it. I forbid myself to understand it. I kept telling myself I won't understand this, but then I was wrong. I was then corrected. I did. It was easy. I regret all of my quizzes, all of my zeros and such. So yeah, thank you for watching, and yeah, thank you. Bye bye.